In real companies, nobody creates Kubernetes users manually. They connect it by LDAP credentials. But how does Kubernetes trust an LDAP user when Kubernetes doesn't even speak LDAP? Today, I will show you how to do it in action. Stay tuned. Hello everyone, my name is Malik and welcome back to my channel. In this video, I will show you how real companies connect Kubernetes to LDAP using Dex as the secure authentication bridge. In a start, let's see what we need to bring up this lab. We need LDAP server. In simple language, LDAP is the database of users. Also, we need Dex server. This is authentication translator. And also, we need to have Kubernetes cluster. As you know, the Kubernetes only trusts to OIDC passports. LDAP cannot issue the passport, so we need something like Dex to issue passports after checking with LDAP. In another language, Dex sits between LDAP and Kubernetes and converts LDAP authentication into OIDC-based authentication. So we can say Dex is an OIDC Identity Provider that translates LDAP authentication into OIDC tokens trusted by Kubernetes. For today's scenario, we need to bring up a Kubernetes cluster. So I did bring up a cluster by kubeadm, a real cluster. To be honest, I have a used server at home and did install this cluster on that server. But if you don't have such server at home, you can bring up a server on one of the cloud providers. For example, you can use Upcloud service provider and bring up a free server on this provider. I will add a link to the description and you can use that for a free server. So after the Kubernetes be ready, it's time to bring up the LDAP server. For bring up LDAP server, we are going to use OpenLDAP. If you search on Google Helm OpenLDAP on Kubernetes, and from the result you can find this link. Just click on this one and here you will see how to install OpenLDAP by Helm on your cluster. Here at first you need to add this repository on your Helm, and after that install by this command. But before install, we need to override some variables. For example, as you can see in this table here, we can override and define admin user and admin password. Let's go in action and quickly bring up our LDAP server to use it for authentication on Kubernetes cluster. So let's go into terminal. Let's connect my cluster. Connected to cluster, and let's start to bring up OpenLDAP server. Let's copy the first one. Back to terminal. Paste it here. Let's, before paste, show you Helm repo list. As you see, at the moment, I don't have OpenLDAP repository here. So let's run this command and let's check list again. Here you see this repository added to my Helm. And in next step, we can install OpenLDAP. So let's back here. As we spoke some seconds ago, before we install OpenLDAP, we need to create a file to override some variables like username and password. I have created this file you see here for the global variables like LDAP domain, admin user, admin password, and so on. For some seconds, let's back to document. Here is the table, LDAP domain. Domain LDAP can be explicit for domain controller and admin user, OpenLDAP database admin user, and this is for password, and also for the replica count. You see number of replication, how many pods we need to bring up for these OpenLDAP servers, and so on. So let's back to terminal. So I did define this one for override values. So let's save it and run this command. Let's check the repo list Helm repo list and let's update the repos Helm repo update. As you see, update all the repositories that I have added to my Helm here. And now Helm search repo this repository. Let's click enter. Look here. In this Helm repository, there are two charts, but I'm going to use the second one as the stack high availability. So by this command, install, name it OpenLDAP. This is the chart here, and also override this file that I have already created. In which namespace? In LDAP namespace. We wanted to have a specific namespace for OpenLDAP, and also add this flag at the end, -- create namespace. If this namespace not exist, please create that one and continue, because if this namespace is not exist, give us error. So it is better to add this flag to override the error. So enter. Look here, OpenLDAP has been installed. You can access the server from within the Kubernetes cluster using this service. Look here, service name, namespace, svc.cluster.local. If I do kubectl -n LDAP get all, look here, OpenLDAP server, OpenLDAP PHP admin, services, and replica set, stateful set database, all of them installed just by one Helm command. So as you see, OpenLDAP is ready. So we need to connect that by phpMyAdmin and define our structure. Here I'm going to deploy this structure in my OpenLDAP. As you saw in override values, I did define example.com as our organization or domain controller, and here we are going to create one organization unit for users and one for groups, and define our users and groups we need for this project. So these questions comes to your mind, how we can access to LDAP at the moment. Let's back to terminal. Here is the service for PHP admin, but as you see, this is cluster IP. Here we can change it manually to node port, and after that by the cluster IP we can access that service. So kubectl -n LDAP edit svc this one. And just let's going down, and from cluster IP change it to node port. Let's save it, and let's again get SVC. Look here, at the moment we can access it through this port, but for user friendly, let's change this port to a round port. So let's edit that again, and going down and change this port to this one. Look here, change. So at the moment, by node IP and this port, we can access to phpMyAdmin. Let's go into browser. Here in browser, 192.168.225.32. Look here, we are connected to phpAdmin. Let's click on login. As you see, the variables here that we did define in Helm override values file, domain controller example.com, and the username is admin. So for the password, if you remember, we did define that as admin password. But if you forgot, you can back to terminal by this command, helm get values from this revision. So just let's enter. Here you see the password, admin password. Let's go into browser and just enter the password and authenticate. Here you see a little mess here. It's related to TLS because at the moment we are using HTTP, that it is not secure. So as this is on lab, we don't need to enable TLS, but we can disable this one to get rid of that. How we can do that? Let's back to terminal. kubectl -n LDAP get config map. There is a config map for phpAdmin, this one, -o YAML file. In this environmental variables, if you see, TLS at the moment is true. We have to change it to false. Just let's back here, edit config map, and this one. Let's go in here and change this one to false and remove this one. Save it. But what happened here at the moment? Config map change. But we need to delete phpAdmin pod and automatically will create by this new change. So let's clear a screen. kubectl -n LDAP get pods. So we need to delete this one, delete this one, --force, delete pod, sorry, and after that this name. Okay, deleted. Let's get pod again. You see, it's going to run again. After this one be completely ready, we can use it. Yeah, it is ready. And now we can back to browser and run it again. Login, admin, password, and authenticate. Look here, successfully logged into server, and that TLS issue gone. So here we need to click on this one and create our organization unit. But you see, it doesn't let us to create any organization unit. So we need to make another change. Let's clear a screen. ls. Here I have created this file with this extension ldif cat base.ldif. Let's edit this one. Our domain controller is example.com. We need to define this object class like top, DC object, and organization. Every LDAP entry must have object class like top because it is the base class for which all other object classes inherit. So think of it as the universal parent class for any LDAP entry. And the second one, DC object, this specified that this entry represents a domain component. and the third one organization. This make this entry represent an organization. We need to copy this one in LDAP server. So let's exit from here, and we need to copy this one to this pod, kubectl -n LDAP get pods. This one, this is the main one that we are using, OpenLDAP server. So we need to copy this file in this pod. Let's clear a screen. Just let's copy this file to this pod in this namespace. So let's enter. After the file copy inside pod, now let's connect to the pod and see if everything is okay. So just kubectl -LDAP exec-it, the name of the pod, --bash ls temp. You see the file is here, and let's see if we can check this one. It seems cat is not here, and it seems this is a very small image and none of these commands are installed. By this command we are going to add this base file to our OpenLDAP server. Just click enter and enter the password, admin password. As we did define this one in the values file for Helm, so show us already exists, but other flags added. So let's back to browser and refresh this one and login, admin password, authenticate. Now as you see, it is clickable and we can click on this one. So here we can define our organization unit and users based on this one. We can define one organization unit for users and the other OU for groups. So let's back here, click on create a child entry. We need to define organization unit, select this one, users, create object, commit, and also click on this one again, create a child entry, organization unit, and groups, create object. As you see, at the moment we have created two OU like this one, users and groups. Let's go in users and create two users like this one, and in groups also create groups. Click on groups, create a child entry and select this one, K8s admins, and create object, commit, and again let's create another one if we like, for example db admins, create and commit. Also let's add another group here. Let's call this one employee and create object, commit. Why I created this one? Because at the moment all users belong to this one, our employee, and after that we can assign this employee to another group like DB admins or Kubernetes admin. So let's go into user and create the first user. We can click here and select user account and define the first name like Bob. Let's use my last name. User ID will be B-Nejat or whatever you like, and let's select a password and let's going down, and from the GID number let's open it and select employee. So at the moment this user is one employee of example company. So let's create object and commit. Let's click on Bob Nejat. Here is the details for this user. If we want to assign Kubernetes admins to this user, we can click on this group, Kubernetes admins, add new attribute. From here, we can select member UID and here add BE-DevOps, for example. Update object and update. So Bob Nejad, the user, is belong to employee as the primary group, and as the secondary group is belong at the moment to K8s admins. For example, if we have another groups and one of these user belong to that, we will go to that group and do the same. How we can verify everything is okay? To verify everything working well, let's bring up a pod by OpenLDAP image and run some command. This pod brings up in default namespace. Let's clear a screen. By this command, LDAP search, it will go and search in LDAP database. -h is the header, this is the address for LDAP. So to access LDAP server, we should use service name, namespace, and this sentence. This is the default DNS for service. And this port, we should connect to this port. And also define the credential user admin and domain controller. Also, if we use the lowercase w, we should add admin password here. If we don't want to use the password here, we can change the W to capital one. And also here we wanted to search in this group. Click enter. Now need the password, admin password. Look here, member UID. So this user at the moment belong to these groups. So everything is okay. So let's exit from here and automatically will delete this temporary pod. Let's clear a screen, and at the moment everything is okay with LDAP server. So let's go into the next step and starting install Dex. Here is the official website of Dex. From the left side, click on getting started. Here, if you do a little scroll down, you will see a reference Kubernetes Helm chart for Dex can be found here. Just click on this one, and here from the first command you need to add this repository on your cluster. Just copy back to cluster, paste it here. Here just type helm repo list. You will see this one added here. So let's back to document, copy this one and paste it here. It will go and search this repository. Look here, this is the latest version for Dex. Here we need to install this one on Kubernetes cluster. Before install Dex, we need to prepare a configuration file. All details about how to configure this configuration file, you can find them here in Dex official website in documentation section. If I go to develop and click on the first one, OpenID, connect provider certification, and scroll down, here you will find a configuration template. Also, beside this template, we need to add another configuration. Let's click on connector, and here we are going to use LDAP because the main source of our user credential is in LDAP. So I'm going to use this one. Click on LDAP and here you see authentication through LDAP. Here also configuration related to connector, and also I'm going to use this one beside the other configuration. Let's back to this configuration. Here there are some variables that are very important. The first one is issuer. Here you should add Dex address, also a storage. So how you can configure this storage? There are several types of storage. From the left side, click on configuration, and in storage section you will find how you can configure and which type of storage you want. You can use it. For example, for Kubernetes, I'm going to use this one, type Kubernetes, and the information will store inside cluster. Also in configuration, if I click on token, here you will see very good information about the token that Dex will generate. Also, I recommend to study this source very well. Let's back to terminal. Also in my cluster, as I did add Dex repository here. So let's search in this repo. Here is the chart that we are going to use this one for install Dex on our cluster. By this command, I will check the default values for this chart. Let's scroll up. From here, as you see, replication count is 1. When you install Dex, it will going and bring up just one pod. If you want, for example, to have high availability for your pods, you can bring up more than one replicas. Also, if I a little scroll down, here you will see HTTPS. By default is false. Normally, communication between Dex and Kubernetes cluster should be HTTPS. So we should change this one to true in config file. Also, you can check all the variables here later. So let's clear a screen and show you the config file that I prepared for this Dex installation. Here is the file that I'm going to use it. In the top of this file, you see I did enable HTTPS. Also, this is the address for issuer. I'm going to use this URL for the Dex and also this node port. After Dex installation, I will show you how to configure this node port. Here is the storage section that I did show you some seconds earlier. This type for Kubernetes, and also the information will record in Kubernetes. Also, how can access to web UI of Dex here by HTTP and HTTPS. By default, only HTTP will be installed. So after we enable this one here I did define HTTPS. By default, when you install it, this port 5556, 5554 and 5558 will be enabled after this one, after HTTPS enabled. If this one is not enabled, only HTTP port and 5558 will be enabled. To enable HTTPS, this one should be enabled, and also automatically this port will be used. And also I did define where is the Dex certification file are located. Also, I will show you how to generate this certification, and also here is the connector section that we already spoke about it. Here you have to define a client. At the moment, we are going to use kubectl. So when you type kubectl, for example, get pods, get nodes, the Dex client will be kubectl, because then you will forward to Dex web UI and request to enter username and password. So Dex will look to kubectl as a client. In document, if I click configuration, from the configuration, if I click on scope and claims, here you will see cross client trust and authorized party, a static client. Here is also very good information. let's back to our config file. So here, a static client. This ID is very important because this one will use in kube-apiserver configuration also. You can give it any name you want. Also, we need to define a secret. Here, I'm using a hard-coded secret here. Also, you can define a Kubernetes secret and use it here as environment variable. Here, also, I did define a volume and volume mount for this certification. Here is a brief story about this configuration file. Before going to install our Dex, I need to provide you information about how to generate this certification file. Here we need to speak about CA certificate. Here we have a Dex server that generate token, or we can say identity provider, and the other side we have Kubernetes, especially kube-apiserver. When Dex server wanna communicate with kube-apiserver, need to trust each other because kube-apiserver by default think this is the fake server. So how can trust to that? Here we need a certificate authority server, or in abbreviation CA. This certificate authority is like a passport authority. So when kube-apiserver receive any communication, any package from Dex server that are signed by CA server, it will accept them. Otherwise, will reject. So the rule of this CA certificate is very, very important. So to ensure it is really Dex and not an attacker, TLS verification happens. It will check, is this certificate signed by a CA I trust? Because this CA should be common between Dex and kube-apiserver. If there is an unknown CA certificate, also kube-apiserver will drop that. Is this certificate signed by a CA I trust? If yes, connection allowed. If no, TLS handshake fails. And in the logs, we see TLS handshake error, bad certificate. So where this CA is using Kubernetes, where we can define this CA in Kubernetes. Hey, Kubernetes, this is the trusted CA. In kube-apiserver, we will define that by this flag --OIDC-CA-file, and the location this certificate is located. So it will tell Kubernetes cluster the trusted CA server located in this path. On Kubernetes cluster, at first I need to create a CA certificate. Just in Google search generate certificate manually, and from the result you will find this link in Kubernetes official document. Click on it, a little scroll down. Here OpenSSL can manually generate certificate for your cluster, and we can use these two commands to generate CA certificate. So by this command I will create a ca.key. ls, look here, this one created. So from this key, I need to generate a CA certificate. So by this command, I will go and generate a CA CRT. Let's enter ls. So from the key, I generated a CA certificate. Now I need to create TLS certificate for Dex server. Again, by this command, I will create a dex.key, And from this Dex key, I'm going to create a certificate for Dex. If I back in the same document page and follow step 4, 5, and 6, we can generate certification request and a TLS certificate for Dex. Let's back to terminal. By this command, I will generate a CSR file, ls, and finally, from this Dex CSR and Dex.key, I will generate a Dex certification. Let's create this one, vim this file, and paste this content here. Save. Let's run this command. Look here, I created this file, Dex certificate, and sign it by this CA certificate. So certification request self-signature, okay. So everything is matched between the CA certificate and Dex certificate. Clear screen. ls, we need CA certificate, Dex certificate, and Dex key. So let's cp CA certificate to etc Dex TLS sudo, and the same for Dex certificate and also for Dex key. ls, this one, CA, Dex certificate, and Dex key. Let's remove this one, cd this location, ls, and let's remove -rf. Oops. ls-latr, and all generated today. Okay, clear screen. Let's switch to another folder, cat dex value. Here is the file that I'm going to use that and bring up Dex server. So here I need to create a TLS secret that I want to use it here. So let's clear a screen, kubectl create secret -h. You see, we are going to generate a TLS one. So TLS, and we need to give it this name, -h grep kubectl. We need to add this one, the certificate and the key file. So let's add both of them here in etc dex TLS, and it's called dex.key, and also for this one the same but different name, crt. So we should create this secret in this namespace. So let's run it. kubectl get secret -n dex. This one created. So let's again cat dex value. So here we need to use them, but let's update the name of them here. Vim dex value. The name of them is Dex CRT and Dex key. Let's clear a screen. Okay, let's back to our Dex story and install Dex by Helm. By this command, we will go and install it on cluster. As you see, it will go and install this chart and give it a name Dex. And also this is the configuration file that some minutes ago we discussed about it in this namespace. And if this namespace is not exist, please create this one. Let's enter, look here, install completed, and also some instruction here. Let's clear a screen. Helm -n Dex, this namespace, list. Look here, first revision with this name, Dex deployed. So kubectl -n Dex get all. Look here, pod, service, deployment, and replica set. Let's get especially services. Look here, service is cluster IP, and 3 ports are involved in this service: 5556, 5554, and 5558. Clear a screen and let's open this file that we use to install Dex. Going up, you see, for HTTPS using this port. So to access Dex by this port on browser, we need to change service from cluster IP to node port. Let's clear a screen, run this one again, kubectl -n Dex, edit, svc, and service name. Going down and change cluster IP to node port. Save it. Look here, the type change to node port. So for access to HTTPS, we need to use this port. But as you saw in LDAP, it is better to change this one as a user-friendly port. So again, let's edit service and going down, find HTTPS and change it to, for example, this one, and save it. Look here, change. Let's open this file again, going in top. So for access to Dex, we can use this URL. Copy this one, clear a screen, and back to browser. And paste it here, enter. Here you see, cannot reach this page. Why we cannot reach this one? Because we are using our internal IP attached to this one. We need to define this one in the local host. If you are using Linux, it's easy, but for Windows, you can search on internet how to add there. But let's show you. I'm doing that by command. Click on Start, type PowerShell, right-click, run as administrator, and add this command. You can find this command on internet, add content, and you see this one. This is the URL, and this is the IP. Enter. So ping dex.example.com. Look here, at the moment, resolve. Control C, let's back to browser again, and enter. Look here, advance, and continue. If I click on discovery, we should see this JSON output. At the moment, our Dex is almost ready, and we need to do some change, and you will see how by kubectl can access Kubernetes cluster. Stay tuned. Let's see how I can connect to my Kubernetes cluster by LDAP credential. At the moment, my operating system is Windows, and also I did enable WSL, Windows Sub Linux, and I want to configure my machine to connect my lab cluster. So the first step, we need to install kubectl in this machine. In Google, just type install kubectl Ubuntu, and from the result, click on this link. This is official website for Kubernetes. And from this document, scroll down, and you can install it by one of these methods that mentioned here. Download the latest release with the command, and so on. Let's scroll down, and I'm going to install using native package management. Just first command, next command, and let's follow the other steps. This one, and also we need to add this link, this one, and finally update and install that. Now kubectl installed. Let's clear a screen and let's type kubectl version. Look here, the latest version installed on this computer. So what is next step? Next step is which cluster we need to connect that. We need to define our cluster. So kubectl config, by adding this flag set cluster, we will define our cluster. So let's clear a screen, kubectl config set cluster, and let's again get a help here and grab kubectl. Look here by such command, but let's change this address to our cluster address 192.168.225, this port 6443, and also let's change this name to my cluster, and also let's add this flag. As you know, we generated the certificate by ourselves and not using the trusted provider. So for that reason, when we want to connect our cluster, we got issue. So for that reason, by this flag, bypass TLS verification. So let's enter my cluster set. If I do kubectl config view, here you will see the cluster definition here. So here you see we need to define which user need to connect this cluster and also give it a context name. The context is a bridge between user and cluster. Let's clear a screen. As you know, we need to connect the cluster by LDAP credential. Let's go into Dex documentation. From left side, click on guides, and from here, click on integration, kube-login, and active directory. Kube-login is a helper tool for Kubernetes and OIDC integration. It makes easy to log in OpenLDAP provider. We need to install this plugin on our Kubernetes, and after that it helps us to define user on our machine. So let's back to Dex document. So to install this one, kube-login, we can use this one, kubectl crew install oidc-login. Crew is a kubectl plugin manager. Also, I have a separate video for this one. I will pin it here and you can watch it later. So at first we need to install crew, and after that we can use it to install this plugin. In Google, just search install crew, and from the result click here, and here you will see how to install that on Linux. Just copy this one and let's run it here in terminal. Here you see, add the following to your bash rc, or this one. Copy this one, sudo vim.bash rc, and let's going down, and we can add it after this one. Save it, run source and .bash rc. So let's run kubectl crew and see if it is installed correctly or no. Yes, it works. Let's clear a screen, and by this command install this plugin. Kubectl oidc-login installed. Let's back to Dex document. Let's going down here, setup kubeconfig. We need to add this configuration to our kubeconfig file. Add a new user to kubeconfig for Dex authentication. Here we are planning for all users in LDAP that need to have access in Kubernetes cluster. So by this config, we add a new user to kubeconfig. But let's going deep dive in this config and see what is written here. At first, we have kubectl config set credential, and after that a name. This one is just a username label inside kubeconfig, not the real login user. Let's imagine there is no LDAP and just one user want to connect to the Kubernetes cluster, so we need to create manually token and add in kubeconfig and also the real username. But here we are planning for LDAP user, so we don't need to define a real user, just we give it a label, Dex user. Dex user can be every user in LDAP. So this section just create a user entry in kubeconfig. After that, we have this section. It's called exe configuration. Everything after this one in this configuration, how Kubernetes should obtain the authentication token. When a user type kubectl get pod and send request to Kubernetes cluster, normally the cluster cannot verify the user. So before the request arrive to the cluster, need to obtain the authentication token. As we spoke earlier, Kubernetes only knows token, not username, not password, only token. So this section that I divided in two sections, it will run kubectl oidc-login get token. It will use this plugin to get token. And this API version, it's a protocol between Dex and Kubernetes cluster to handshake with each other. The next section are the parameters. When you run kubectl get pods, will send to Dex, and Dex will provide you a page to enter your username and password and then generate a token for you. So we need to run this command. When we did install Dex, we were using this configuration file. So let's here, we did define a static client and the ID was Kubernetes. So this ID should be matched with this one. Also, client secret. Look here, we have a secret here. We are going to use the same secret in this command. And also you see a redirect URL. When we enter our credential on Dex web UI, it will go and bring up a minimal web server on Dex and will generate token. So this one is the address. As you see, localhost is a localhost minimal web server. And this one is for bypass TLS verification. Let's run this one. I did copy that here and remove the backslash to be a unique command. Control C and let's run it on terminal. Enter. Dex user set. If I run this command again, here you see in the user section, this configuration added. Now we need to define a context. Let's back to this presentation by this command, kubectl config set context, give it a name and the name of cluster and the name of user. This is the name of user and this is the name of cluster, my cluster. So let's run this one. Also, I remove the backslash, copy, clear screen, paste, and run this one again. Look here, context, cluster is this one, and user is this one. Clear here, and kubectl config get context. Look here, this is the only context and cluster we have here. So we need to use this one. By this one, kubectl config use context. Which context? Dex context. This one. Enter. If run this one again, here you will see a star. It means this is the active cluster. Let's go into Dex document. Let's a little scroll up. Here, configure Kubernetes with IDC. To make Kubernetes API server accept an OIDC token from Dex, we must configure the API server with some flags. Which IDC server to trust? We need to define, hey, API server, this is the Dex server address. Also, we need to define which client ID is valid. If you remember from some minutes earlier, we did define this ID in the Dex configuration and also in oidc-login on user computer. So the generated token by Dex should contain that information. When a token arrives to the API server, should represent the username and the groups. For example, we have a group called Kubernetes admins. So the Kubernetes should determine this group exists, and after that check it with the rules on the Kubernetes. So if can authenticate, let it access. So we need to add this configuration in kube-api server. Let's quickly go into terminal, connect to cluster, going to root, and we need to edit kube-api server from etc Kubernetes manifest kube-api server. Here I already added them here. Here is the Dex address, client ID, the username. We can change it to user ID or email, but we are using sub to include a unique subject and also include the group. For example, that user belong to some specific group. So the kube-api server need to determine that groups. Also, this certificate that we did generate when we did install Dex. So after that, you can save it and it takes some seconds to back online. You can check it by watch CRI-CTL PS and then it will show you kube-api server back or not. So everything configured on Kubernetes kube-api server and also on the user computer. So let's run kubectl get path. Enter. Look here, as I am using Windows sub Linux, it is like a pure Linux server. So cannot find any browser on Linux. You see, search for Firefox or Google Chrome or the others and couldn't find. So here type error, couldn't open the browser. If you are using PowerShell, automatically redirect you to the browser. But here couldn't. As you see in the last line, please visit the following URL in your browser manually. Let's copy this one, back to browser, open a new tab and paste it here. Look here, it requests to enter username and password. My username is B-Nejad, as we did define in LDAP server, and the password. Let's log in. Oops, look here, the information retrieved from LDAP server couldn't find this attribute. Mail. Let's back to LDAP server, login, open this one, user, Bob Nejad. Here we don't see any email. So we can add attribute here. For example, let's going down, email, and define, for example, B-Nejad @example.com. So update object, this attribute added here and update it. So let's back to terminal, Control C, clear a screen, run it again. Copy this one, back to browser, run it again. Username and password and login. Look here, you see the error is gone. So grant access, authenticated. You have logged into the cluster. You can close that window. So we can close this one and back to cluster and see what happened. So let's see what happened here. Let's, before solving that issue, going to Google and search for redirect a URL to browser page from WSL terminal. We wanted to get rid of the manual copy paste and automatically redirect to browser. So from the result mentioned here, by installing WSLU, we can overcome of the first issue. Let's install this package, WSLU. WSL can open the Windows browser automatically. Let's test this one, clear a screen. Let's run this one again. So it seems still the last one in cache. By run this command, it will clear the oidc-login cache. Okay, let's clear a screen. Let's run it again and see what will happen. Look here, automatically open the browser. Let's enter credential and login. Grant access, authenticated. Let's close this one. You see, still we have this issue. Let's go into cluster, kubectl-index get path. Let's check logs for this one. Look here. It could connect to LDAP server, get information for user. As you see, login successful, and just show us batch certificate. It seems for handshake with TLS, we had an issue. Also, I took this section of logs and pasted here to make more focus on that. As you see, all the information for this user retrieved from LDAP server. If you have a closer look to this log, here is the username and also email address. But the group is empty. As you know, this one is very important because when this data arrive to Kubernetes cluster, need to know this user belong to which group, because we want to do authentication and authorization based on groups. So let's clear a screen, and also let's check another thing. Let's get token manually. If you remember, we added this flag in kubeconfig some minutes ago. So let's run it and it will generate a token. We need to see what is in this token. Just type echo and this token from here to here. And let's decode this one with JSON output. Look here. In this one, we have Dex. In this one, we have issuer. It's correct. Authentication ID Kubernetes is correct. This is the expire time. How long it will take to be expired? Here, we don't see any group because we need to allow this group. At the moment, we don't see that in the token. So until now, we have to issue one TLS certificate and another one. Why we don't have group here? Let's clear a screen. Back to cluster, cat dex value. This file we use to config our Dex server. In this section, in config section, for group search, it will go and search in groups in this domain controller. For the filters, it will go and search group of names. Look here, group attribute member. So Dex is expecting member attribute. Let's going to LDAP. Here is this group K8S admins. Let's see in these attributes. Do we have member? No, we have member ID. Here to fix this issue, we can do two things. Here, add a new attribute called member, or fix this one to member UID. I prefer to change this one to member UID. Here also we need to change object class to what? Let's back here. Object class is this one, POSIX group. So we need to fix that. So let's back quickly to cluster, clear a screen, vim dex value. At first, let's fix this one. Object class is this one. And group attribute, let's change it to member UID. Also for user attribute, let's change it to UID, user ID. So let's save it, clear a screen. We need to update Dex by Helm. But before that, I need to do one thing. kubectl Dex get service. We did change this one to node port manually. I need to revert that manually also. So let's do edit service Dex. Let's going down and change this one to cluster IP. Okay. So next I need to update Dex. Clear a screen. By this command, let's upgrade it. Enter. Okay. Updated. So clear a screen. Again, let's quick back here. Change this one to node port. Save it. Get here. And once more. HTTPS. Node port to 31. Fix it. Also, I need to restart Dex server. kubectl-dex-n-dex get deploy. I need to restart this one. So kubectl-n-dex rule out restart -h grep kubectl deployment, this deployment restarted, get pods, it's running, nice. So let's back here. Before run again kubectl command, let's go into Dex document. Here it seems I forgot to add this one in the set credential. So let's add this one in the command again. So let's add this one at the end of this command as you see. So let's enter. It's set kubectl config view. Look here, add it here. kubectl get pods BE-DevOps and login grant access. Back here we will fix certificate on. but let's check the generated token by also add this flag at the end, and let's read this token from here to here, copy, echo this one, give JSON output and decrypt that. We see the groups here. So now we can define RBAC based on group authentications. Also, let's fix certificate error. So here at the moment when we type kubectl get paths, we got this error. We should find out what is this error. Let's go into cluster and check kubectl -n dex logs dex, this one. Look here, we have this error, bad certificate, TLS bad certificate. If you remember, some minutes ago we spoke about certificate, and I told you if Dex certificate not trusted by CA, TLS handshake fails, and we will get this error, bad certificate, TLS handshake error, TLS handshake error. So where this CA server is defined, if you remember, this CA certificate should be in this path in kube-apiserver. So let's go into kube-apiserver, sudo -i, and let's check it here. Look here, we have a wrong name. So let's remove this one and change it to CA certificate. So let's save it and wait for some seconds to back in service. At the moment it is in running. Yeah, delete it and back to service. Control C. Let's back here, kubectl get paths. This is on server, okay? So kube API is work well. So let's back to user computer. Let's run this command again. B-Nejad, password, login, grant access, back to terminal. Look here. So it seems everything worked well, but note it forbidden. Cannot list resource nodes. So it seems this group K8s admins have no access to cluster. So this one comes to our mind. We should play with RBAC rules. Let's go into cluster, kubectl get cluster rule. Let's scroll up. We have this rule, cluster admin. As this group are cluster admins, we need to bind them with this one. So we need to have a cluster rule binding. Clear screen. I have created this file. It's a cluster rule binding, and we'll bind this rule to this group. So by kubectl apply -f and this file, this one created, if back to user machine and run this one again, look here, we have access to cluster. So at the moment, a client by LDAP credential can access to cluster. I hope you enjoyed this video, and if you like it, please add your feedback in the comments section. Thank you so much.